In this episode, we're going to look at patterns, and in front of us here we have a quadratic pattern, and we have to determine the constant second difference. So we have 5 minus 4 minus 19 and minus 40. So the difference between minus 4 minus 5 will be minus 9. And the difference between minus 19 and minus into minus 4, that will be minus 15. And we have the difference between minus 40 minus into minus 19, and that will give us minus 21. So this is our first difference. Now we need to get the second difference. So we need the difference between this, and the difference between minus 15 minus into minus 9, that's minus 6. The difference between minus 21 minus into minus 15, that is minus 6. So we can conclude and say, therefore, the second difference is equal to minus 6. The second question says determine the nth term, or Tn, of the pattern. So this is actually looking for the general formula of the pattern. So as we learned from our first video, the general term for, or the general formula or general equation for anything that has to do with quadratic or quadratic patterns or the hyperbole, so it is f at x equals a x squared plus b x plus c. So now the general formula for a quadratic pattern will be Tn equals a n squared plus b n plus c. So all we do is we substitute the x for n. So now we need to find a, b, and c. So a equals the second difference divided by 2. So a equals, now remember that our second difference was minus 6, so we have minus 6 over 2. So a will be equals to minus 3. Now for b, formula is the first term, which is f1, we'll just denote it f1, the first time of the first difference, minus 3a. So the first term of the first difference is this one here. So this is our first difference, and this is our first term. So that's minus 9 minus into 3. So the answer here was equal to 0. And now for C equals to the first term, which is T1 minus A minus B. So that is equals T1 from our pattern is 5. So we have 5 minus A, which is minus 3, minus B, and B is 0. So that is equals 5 minus into minus 3, so that's just 5 plus 3, which is equal to 8. So now you can say therefore Tn equals, taking A is minus 3n squared, B is 0, so that term will not be there, and plus C, of which our C is 8, plus 8. This question asks which term of the pattern will be equal to minus 25,939. So now we have the general formula, and that is Tn equals minus 3n squared plus 8. So now all we need to do is to equate this formula to the value of the term that we're looking for. So that is minus 25,939 equals minus 3n squared plus 8. So now transposing everything to the left hand side, we will have minus 3n squared, sorry, it's a plus 3n squared minus 8 minus 25,939 equals 0. So 3n squared minus 8 minus 25,939, so that will give us the sum of 25,947 equals 0. So now to get rid of the 3, we just need to divide by a 3 throughout the equation. So we'll have n squared minus 8,649 equals 0. So I will not waste time trying to factorize this. So this looks like a difference of 2 squares, so I'll just test it. So looking for the root of 8649, the root is 93. So just like we predicted, this is a difference of 2 squared. So we have n plus 93 into n minus 93 equals 0. Therefore n equals minus 93 or n equals 93. So 93 or T93 T93 will be equal to minus 25,939, and we can test this by substituting into the equation. So that will be T93 equals minus 3 into 93 squared plus 8. So that will give you an answer of minus 25,939. So in this term, given the first three terms of an arithmetic sequence, and these terms are 2k minus 7, k plus 8, and 2k minus 1, and you are required to calculate the 15th term of the sequence. So here we need to first find the value of k, and to do that we first need to find the common difference, or we need to use the common difference root. So the difference between these two will be k plus 8 minus 2k minus 7. The difference between these two will be 2k minus 1 minus k plus 8. So now we know that the common difference will be equal throughout, so we can say common difference, which is denoted as d, is equal to another common difference d. So we can now take k plus 8 minus 2k minus 7 equals 2k minus 1 minus k plus 8. So we have k plus 8 minus times that, so we have minus 2k plus 7 equals 2k minus 1 minus k minus 8. So now we need to take everything to the left hand side and look for like terms. So we will have k plus 8 minus 2k plus 7 minus 2k plus 1 plus k plus 8 equals 0. So now looking at like terms, we have k and k. So this k will cancel with this one, and therefore cancel with the minus 2k, and we'll be left with minus 2k and now we have 8 plus 8 plus 7 plus 1. That will give us positive 24 equals 0. So we can say minus 2k equals minus 24. To get k alone, divide by minus 2, divide by minus 2. We have k equals 12. So now we need to go back to these values, and we need to substitute k, the value of k. So now we'll have 2k minus 7, we have k plus 8, and we have 2k minus 1. So substituting k here, we have 2 into 12 minus 7, where we have 12 plus 8, and here we have 2 into 12 minus 1. So this here will give us 17, and the following one will give us a 20, and 2 into 12 minus 1 will be 23. So now, in order to get the general formula for this pattern, now we need to get the common difference, the actual common difference. So the difference between these two, and that's d, equals, we have 20 minus 17, that's 3, and 23 minus 20, that's 3. So our common difference is 3. So the general formula for an arithmetic equation is Tn equals a plus n minus 1 times d. So that's equals to our Tn is 17, so that's our first time. Also our a is our first time, which is 17, plus n minus 1 times our common difference, which is 3. So we have 17 plus 3n minus 3. So that's 3n plus 14. Now to get the 15th term, so we need to say t 15 equals 3 into 15 plus 14. So that will give you an answer of 59. So that's the final answer. So on this question, we are required to calculate the sum of the first 30 even terms of the sequence. So now we'll have to look at our sequence. So we have 17, 20, 23. So what we'll need to do is, well, let's write the terms down first. So we have 17, we have 20, we have 23. So now in order to get at least 3 even terms, we need to add more terms onto this sequence here. So all we need to do is add 3. So 23 plus 3, that will be 26, and 26 plus 3, that would be 29, and 29 plus 3, that's going to be 32. And from this sequence we need to extract all the even terms. So the first even term is 20, and the second one will be 26 and 32. So now we need to get the common difference for these. So D will be equals to 26 minus 20, that's 6, and 32 minus 26, that's 6. So now we need to get the general formula for this new even sequence that we have. So Tn equals A plus into n minus 1 times D. So our first term of this sequence is 20, so we have 20 plus n minus 1 times our common difference, which is 6. So we'll have 20 plus 6 minus plus 6n minus 6. So that will give us 6n plus 14. So now that's Tn. So now the sum of the first 30 terms will be given by Sn equals n over 2 into 2a plus n minus 1 times D. So that is 30 over 2 into 2. Our first term is 20 into the 30th term minus 1 times 6, which is D. So entering this into a calculator will give you 3210, and that would be your solution. So everyone, the pattern section I will divide into 3 parts. So this is part 1 of a 3-part video. And guys, like always, if you like what you get here, please leave a like and perhaps subscribe, and I will catch you on the next video.